Welcome back, my friends. In this video, we're going to talk about how you can find the equation of an exponential function. So I'm using this example from your Lumen Interactive textbook. If you want to go and check this out in example 3, you can actually see their solution. And maybe you want to compare that with the work I'm doing here, or maybe you want to watch this video first. Whatever you like, I just wanted you to know that's available for you. So let's take a look here. In 2006, 80 deer were introduced into a wildlife refuge. By 2012, the population had grown to 180 deer. The population was growing exponentially. Write an algebraic function, n of t, that represents the population, n of deer, over time, t. So they're giving us quite a lot to work with in this problem. They know that we have an exponential function that we want to find, and they know that it has to do with the number of deer over time. So let's go ahead and write just a generic exponential function having to do with population. And then we'll fill in the blanks. N of t is equal to a times b to the t power. So in this, we have a, which is our initial population. We have b, which is our growth factor. This is how the population is increasing. And we have t, which stands for the time. So we should be able to put in a specific time and get out a population value at that specific time. And so here's what we can do to write this, is we're going to use the information from the problem to find an exact value for A and an exact value for B, and then we'll be able to put those into the equation and we'll be done. So that's all we have to do here. So let's look at what they say. They say in 2006, we have 80 deer. Then in 2012, sorry for that. In 2012, we have 180 deer. So what we want to do is find a way to figure out the initial population and the growth factor. So one trick we can do here is we can just say that 2006 is the start of our function. That 2006 is the start of our function. I'm actually going to go ahead and circle that in yellow because it's related to finding our initial problem. So let's go ahead and just say, let's have t as a variable be years since 2006. So when t equals 0, we have years are 0 since 2006. So that's talking about the year 2006. When t is equal to 1, that's 1 year later. 2006 plus 1. So that's the year 2007. So then in 2012, t would actually be equal to 6. And then that would give us the year 2006. 6 years later is 2012. So now what we've done is given ourselves an initial population, because initial means when t is equal to 0. So let's look back at our information. When t is equal to 0, our initial population is 80. So we can already begin to fill in this function. We know now so far that n of t is equal to 80b to the t power. And t is our variable, so that's already taken care of. What we need to do is we need to find some way to figure out what's our base. What is our growth factor? So we've already used the fact that in time 0, our population was 80. Now we know what we need to figure out is we need to use when t is equal to 6, we also know our population. When t is equal to 6, we're in the year 2012, and we have 180 deer. Ooh, I only wrote 18. Terrible. We had 180 deer. We had 180 deer. So when t is equal to 6, let's do this in blue since this has to do with the base. So when t is equal to 6, our n of t is 180. And we'll be able to use that to solve for b. Let me show you how. So our n of t will be equal to 180 when we have 80b to the 6th power. Here I'm plugging in t is equal to 6, and I'm plugging in n of t is equal to 180 right here. And now we just need to solve this equation for b. Don't get stressed out. It's not as bad as you think. First, we're going to isolate b here. We want to isolate this variable. Then we'll worry about how to handle this exponent. So first, I'm going to divide each side by 80. Divide by 80. And then I'm going to simplify my fraction on the left. I'm going to notice that they have a common factor of 10. So that becomes 18 over 8. And then I notice even more that that has a common factor of 2. So I can divide this by 2 and divide the numerator by 2 and the denominator by 2. And end up with 9 over 4. And then here 80 divided by 80 is equal to 1. That cancels out and we're left with b to the 6th power. Now we have to worry about how to handle this 6 here, because we're trying to solve for b, not b to the 6th power. We can use our laws of exponents that you may have studied in your algebra class. So here's what I can do, and it's kind of a neat trick. I want to do the same thing to both sides because I'm solving an equation. So I'm going to do the same thing to each side. And what I'm going to do is I'm actually going to raise this to the 1/6 power and raise this to the 1/6 power. And what happens is there is a law in the rule of exponents. It's called the power to a power law. And it says if I have a raised to the b power and all of that is raised to the m like that, then that's the same thing as if I take a and I raise it to the b multiplied by m. This is one of our exponent laws. So I can multiply together 6 and 1 over 6, and that's going to give me 1. So I end up with 9 divided by 4 to the 1/6 power is equal to b to the 1st power. Now, I don't expect you to be able to do this calculation in your head. This is the kind of thing you will likely need a calculator for. Let me show you how you could enter this into a calculator so that you would get the right answer. I would type in 9 divided by 4 inside a pair of parentheses like this. Then I would raise it to the exponent, and I would use parentheses 1 divided by 6. That's going to give you the correct answer when you type it into your calculator that way, because it's telling you to take the whole fraction and raise it to that 1 divided by 6 power. A lot of times students will leave off the parentheses, and your calculator doesn't read this correctly. Your calculator says, oh, cool, I'll raise it to the 1st power, no problem. Then I will divide the whole answer by 6. And so you'll get the wrong answer because that's not what you want your calculator to do. So you have to be very clear and very precise with your poor little calculator. It only knows what you tell it to do. So use those parentheses and make it very clear for your calculator what you're asking. That way you can get the right answer. So if you type that in and you get the right answer, I'm going to ask you to round that to, let's go ahead and say 4 decimal places. And what you'll end up finding is that 1.1447 is approximately equal to this b value here. So now we are ready to have our equation. We can say n of t is equal to our initial population of 80 times our base, our growth factor, 1.1447 raised to the t power. And this would be our final answer. This would be our lovely little equation right here. In the next video, I'm going to show you how to find a function that goes through 2 points on the graph. So this was a real world type of problem. And in fact, population modeling is one of the things that exponents are most useful for. But we sometimes are dealing with things in a little bit more abstract of a way. And so in the next video, I'll show you how to handle something like that. All right, stay safe, and I'll see you in the next one.